For the piecewise functions, you need to be careful and think about everything. What are we working with? So, usually this is how I explain it. I name each function to be function number 1, function number 2, and function number 3. And then I sketch the diagram of what is going on here. I can see that the point number 1 and point 2 are troublemakers from here and here. Then I want to see which part of this diagram will require which function. When x is smaller than -1, that's to the left from -1, I'll be working with the function number 1. When x is between -1 and 2, that's going to be function number 2. And then after 2, function number 3. But what is happening at those 2 points? Locate the equal sign. The equal sign ended up to be for the function number 2 for both points. So it will be function number 2 here and here. Now, for the question A, h of 2 is, where should I look if I'm looking at point input 2? Either you look at here, you see this equal sign, means we're looking at the second function, x squared plus 1, or my diagram helps a lot. Here is my number 2. It says look at equation number 2. So I will be plugging everything into function number 2. That is 2 squared plus 1, which is 5. What is h of -10? Well, -10 is over here on the left from -1. So I'll be looking at equation number 1. That is just x. So it's going to be -10. Do you understand that we're plugging it into this line, the first line? But this line is y equals x. So if you plug -10, it gives you -10. What is h of 0.5? 0.5 seems to be in the middle over here, so it's going to be again equation number 2. 0.5 squared plus 1. That is 0.25 plus 1. That is 1.25. h of 2.777. That is the one that's finally hit the equation number 3 because it's on the right from 2. So it's going to be, what is the answer for that? What is the equation number 3? That is y equals -1, which means no matter what we plug, the answer is still -1. That's a constant there. That's why it's a funny question. There is no calculations needed. Same for h of 13. When I plug it into equation number 3, which is just y equals -1, the answer is still -1. So that is pretty interesting. Number 3, number 2, number 2, number 2, number 1. We're done with A. B asks us to sketch carefully the graph of this piecewise function. Well, let's look at it carefully. 1, 2, 3. Let me sketch the y-axis and the x-axis and the 0, 0 part. So the function number 1 is y equals x. That's a function number 1. Y equals x. Y equals x is just a line, diagonal line. Let's put it in green. Y equals x. That is my line number 1. But the thing is, we don't need all of it. We need this function only until -1 without including -1. So I will find -1 and only leave this part. So another part is not needed. Maybe I can do the dash part. Y equals x. Now in pink, let's do function number 2. That is the quadratic function, parabola. X squared plus 1. X squared plus 1. That is a parabola shifted up by 1 unit. So it used to be at 0, 0, but now it's shifted to 0, 1. How do I know? When I plug 0, it gives me 0 squared plus 1, which is 1. And just knowing transformations of graphs, I also know that it's parabola shifted up. I need it only from -1 to 2. So definitely I need it starting from here, and then finishing at 2. But what is the output if I plug 2 into the parabola? What do you think? It's going to be 2 squared plus 1, that is 5. So I need to find 5, let's say it's here, 2 comma 5, and then stop after this. And I also stop after minus 1. I also need to think, should I include those points or not? Because of these equal signs, I should include minus 1 and 2. So I will put filled in circle here while this one was open, and then filled in circle here, which is 2 comma 5. This one is minus 1 and 2. And the last part, equation number 3, is y equals minus 1. Let's make it blue. 3, y equals minus 1. That's just a line. Let's find height minus 1, which is this. Draw a line, horizontal line. But I need it only after 2. So I'm finding 2, here it is. And then I will make the open circle because I already closed it for the parabola and because it's a strict inequality over here. And then just have this line only after the input x equals minus 2. But this height is minus 1. That is the graph. First it is in green, then parabola, then line. Looks pretty nice, I think. Maybe I should have put the parabola part a little bit higher to make it more realistic. Higher like so. Close it. This is 2 and 5, and then dash after this. This is my piecewise function, and in the future you will learn that it is discontinuous and it has 2 jumps. It jumps here from line to the parabola and then from parabola to one more line. Pretty interesting example.